Analyze the clue, at least up here in the front. The clue was right, ironically, all of this is clue. And he translated it to be x plus 2y is equal to 108. And he y equals, what was it, 108 minus x over 2? But that's all the clue. That's in our handy-dandy notebook. What are we actually supposed to be working with as our primary? We're taking a derivative, but of who or of what? Remember, optimization, snazzy name for you're finding a max or a min. Primary is the guy whose max or min you're finding. Read the problem. What haven't we dealt with yet? Yeah, because this is just x and y, right? All of that, x and y. All of this, clue. So guys, I mean, just process of elimination, it has to be this fact, right? Who? Needs to be maximized. So our primary is going to be the product. Oh, well, we need to make another equation. So Nick analyzed the clue for us, but what's the actual guy we're taking the derivative of? Product, x times y. What can we call it? I mean, you can call it A for area, but that's kind of awkward. You can call it P for product. You can call it S for so much fun. I don't know, something. Now, take Nick's clue, and what can we do? Yeah. Keep going. Now plug in the clue to the product who we're trying to maximize. And then I think, Nick, we're trying to take the derivative. We're trying to do critical numbers. So once you plug in your clue, then take the derivative, then find the critical numbers, and then think who is the, what is the, where is the max. Okay. If you had tried to simplify that, you would have gotten 0 equals 0, and you're like, oh. Because when you plug something into itself, yeah. So I was like, wait, no. But the concept was right, just the place you plugged it in was off. For those of you guys just joining us, we have a few people absent. Rachel, we hope you passed. Grace, we hope you had fun. We're doing this in the back of our homework spiral, then we're going to bust back into our notes and do examples till the end. Meanwhile, I'm going to start Jean's Day Money over here to the right. I mean to the left, my left, your right. Allie, it should come back towards you and you just put it on my desk. If you guys do have any items at your house that you're trying to clear out or your mom's trying to clear out, maybe she makes like a thrift store pile, etc. Maybe you have junk in your room that you're supposed to clean out. You can drop it by school this afternoon, this evening, tomorrow. For the rummage sale, it'll be a huge blessing to Senior Brache. Otherwise, if you have elementary siblings, there is a Parents' Day out on North Campus tomorrow, aka you can drop off your younger siblings, and the missions team to DR would love to babysit them from 10 to 2. So if it's something like, you're like, sweet, I can get rid of them for a few hours. Hey, Mom! Anyway. And we would love to babysit them for a small fee. But other than that, go to the play tonight, tomorrow. It's a strangely busy weekend, but in many different directions. So. Okay, I'm going to start playing. Did anybody think of rewriting first to make life easier? Thanks, Iris, I got it. Did anybody think of rewriting first? Once you learn the quotient rule, you're like, oh, I always have to do that. No, you don't. Why not just make the divided by 2 be a 1/2? And now it's efficient. And then you can multiply and be like, yay, derivative. Anyway, no judgment. It should have worked with quotient rule. Is that what you guys did? Is that what everybody did? No, p prime equals 54 minus x, but the critical number is 54. Because the derivative, you bring down the 2. 1x. Well, but x times x is x squared. Hmm? Okay. Because that's an x and that's an x squared? Is that what you mean, Christina? Do you mean up here?
No, below. How come it's 54x if you distribute it?
Oh. I haven't taken a derivative yet.
Oh.
I'm just rewriting.
Okay.
And then I took the derivative. Yeah. Sorry. I'm just rewriting. So all of this is rewrite. Yay, let's go. Got it. If you'd done the quotient rule, though, if you had the quotient rule, you would have gone straight to the derivative here, and you would have had bottom d top, 108 minus 2x, minus top d bottom, which is just 0, all over bottom squared. You would still have gotten it, I think, because then I guess that makes it harder than it has to be. Why not just reduce, I guess, right? 1 and 2. Then you would end up with 108 minus 2x all over 2. Isn't that 54 minus x? Oh, we could have distributed him. From quotient rule, product rule? Okay, so then that would be, they all end up being the same. Something that, if I were you in a colored pen, I would write just for you guys to think about would be rewriting makes life easier. Remember, I warned you guys, because you just didn't have enough experience when I said it, though. I was like, as soon as you learn the quotient rule, or as soon as you learn all the derivative rules, you're like, oh, this is nasty, so I have to do it the nasty way, but you don't. Like, rewriting helps a lot. But we can do it. Minus x times 1 plus first d second, which would be negative 1. Then d top, that times 1 plus that times negative 1. Yeah. Minus top d bottom, which is 0 all over 4. Cool. Instead of rewriting, you end up with the same thing. That's going to be minus 1x minus 1x. You might have made like a little derivative mistake in your product rule, but then that's also going to be 54 minus x. Oh, you didn't do quotient rule?
Yeah, I did like the product and then...
Okay, so that would be, let me rewrite. Like that? So second d first plus first d. Did you do this with 1/2 being a coefficient or quotient rule? Okay. So bottom d top minus top d bottom all over bottom squared. Bottom d top, negative 1, top d bottom, derivative of 2 is 0, all over bottom squared. Okay, so that would end up with 108 over 2 minus x times 1 plus negative 2 over negative 1/2 x, which ends up being 54 minus x. See if you can find your mistake in there. Yeah, it could have been. It could have been anything from like the negative, and you didn't think a negative ends up being a negative 1. There's a lot to keep track of. But that would have the proper way of how you did it. Yeah. Either way, the critical number is 54. But guys, 54 is just the critical number. What are we supposed to be actually analyzing for? The max. So what do we do with critical numbers for maximums? If it's the max, we would test with endpoints. Do we have endpoints? Not explicitly stated endpoints. But if we come back to our clue, doesn't our clue give us some sort of restriction as far as how big x can be? So remember yesterday when we were trying to think about the fence and we were trying to think about cost, and we're like, okay, what's the lowest x can be? Well, 0, but it can't really be 0, because if it's 0, you don't have a rectangle. Like, you don't have a rectangular plot of land. It's just a fence next to a fence and nothing in between. So we were saying, okay, x can go down to 0, but not actually be 0, or else you don't have a rectangle. And x can go up to, how do we figure out 1,000? Well, because you only had $6,000. So if you spent all your money on the x fencing and forgot the y fencing, you still can only spend up to $6,000. So $3. That would still just be only 1,000 that you could actually get for x. But they were open intervals, because if you spent all your money on the x fencing, well, then y would be 0, and you wouldn't have a rectangle either. So let's kind of take that and apply it here. The clue says you only can go up to 108. So what's the smallest x can be? Well, it's positive 0. How high can it go? Well, let's say we use all this 108 on x. Let's say y is 0. Well, then x can still only go up to 108. But can x actually go up to 108? No, because then y would be positive. Y would be 0. So we have it, but it's open, it's not closed. So do we have to test the endpoints? No. But what do we need to do? To make sure it's a max, we do need to go ahead and say, okay, starting at 0, going up to 108, testing it. Or we could plug in before 54, which would be a negative, after 54, which would be a positive. So what do we got? So, sorry, before 54 is a lower number. Why did I do that backwards? I have no idea. I should have actually chosen a number like 20, and that's a positive number. Chosen a number like 70, and that's a negative number. Goodness gracious. Okay. What do we have at 54? What's the function doing this whole time? Going up. What's it doing the whole time after? Going down. It's not just a max. It's the max. But either way. Wait, what are we supposed to be finding? 54? What else are we supposed to be finding? So once we have x is equal to one number is 54, how are we going to go find the other number? Yeah, you have a clue. So go find your clue and say, oh, hey, wait, hold on. I got a place to put them. 8 minus 54 is 54, and 54 divided by 2 is 27. My two numbers, 54 and 27. Does a lot of this have to do with reading comprehension? Yeah. With mathematical background, right? But reading comprehension, but is there also calculus involved? Yes, and just because you get a number, is that the answer? Not necessarily. Oh, hey, here's a defense. Yes, that is the math. What are they actually asking for? Let me make sure I give them all the information they want.
Because, no, I'm not saying simple as in that, but like I got that answer before we even did anything.
Most of them can't be done like SAT. Kind of like a little like, oh, let me work through the numbers and try to, does that make sense? So on the SAT, they can ask you a question like, given these restrictions, what's the largest rectangle possible? And a lot of SAT people teach it's always a square. Like some of it's just logic. And so this is a very logical one. Usually these types don't show up on the AP when they're just dealing with, and you can just kind of like eyeball. It's cool that you can. Like my dad could probably do this too. He is a history teacher, but he does summer school for algebra, and his such that he's able to like problem knowing all the procedures, and he gets the answer almost every time when he's doing summer school. But he struggles with like, oh, stink, the kids have to learn how to do it. Because he's like, oh, it's this. And they're like, why? With like the 2 trains and all that. So it's really, it's like, yeah. But the AP tends to do things more like this. And so we're seeing how calculus is actually behind the why without having to teach someone else whose brain doesn't work your way, like, and find it. There is math behind it, but it applies it to stuff like this. Or like yesterday with the rectangular plot of land, and that one, because $3 a foot and $2 a foot, you probably still could have kind of problem solved that one. But with the $3, $2, no longer the maximum is a square, because now you have cost that's messing everything up. Yeah. And these are still, in a sense, basic problems, because like in a business, you're going to have a lot more variables than just like, oh, hey, the money for the fence. You have like the gas to go to the place to buy that. Anyway, there's a lot of different things to consider. But good question. Because, yeah, you're totally right. You could play with that one and find it out without all the math. Guys, let's go to notes. I know you're in your homework spiral. Sorry. Let's go to our notes. Homework spirals. I just wanted to do one that was similar to yesterday, see how far you were able to get. A lot of you guys were playing with the whole, like, oh, 2 numbers, an X and a Y. I think the clue that we missed was, it's really easy to miss primary, the secondary, or switch them. To either totally miss the primary, the secondary, aka the main point, the clue. To miss one of them in your first time around or even your second time around. The AP likes to sometimes throw in something extra and you're like, that doesn't make any difference. Well, sometimes it does and sometimes it doesn't. So I can't just tell you every single piece to the problem has some sort of meaning that you have to apply. They like to throw in extra stuff too. But reading comprehension, what have you been given? What are you supposed to find? Yeah, you're supposed to find the height and radius, so let's assign some variables to that. You guys can totally use x and y if you like it, because with x's and y's, we're kind of used to dealing with them, with derivatives and whatnot. But what else could you use? H and R. So just for sake of argument, I'm going to use H and R, because calculus doesn't have to just be done with x's and y's. So find the height and the radius. Okay, that's going to be H and R. And do you see why I'm underlining parts of the problem? You can kind of disregard that. Like your mind doesn't have to stress about that part anymore, right? Okay, what else do you see? Good, that's an important word. And I think even the CalcAB kids from last year, they got stuck in the optimization. Ew, I hate that. Wait. You see the word minimum in a problem and you're like, oh, critical numbers. Like it's not a big deal. A minimum we did all last chapter, or all chapter 3a. Be scared by, oh, minimum, sure, okay, calculus. Uh-oh, minimum of what though? Do you guys see it? Okay, so I found my primary minimize amount. Okay, well, but why am I changing to blue? This is something of a cylinder, not area though, it's cubic. Volume. Is volume, the inside, the same as the amount of material on the outside? Think about a can. Is the stuff you fill the can with the exact same thing as the stuff that the can's made of? No, so I have to separate these two. Does that make sense? Do you guys get that this one's going to be a surface area? Whereas this one's volume? That's how I knew to separate the. Look, we've done everything in the problem. The AP might, I don't know, with something about like, hey, it has to do with a soda manufacturing company who's trying to cut cost and da-da-da-da-da. Sprite, I don't know. Cranberry. Anyway, so, coming back. Even though the AP might throw more information, we've dealt with all the important stuff. So my clue. V equals, anybody know a cylinder is pi r squared h? care about the open at the top if it comes to volume? Wait, I don't even need to name it V. What can I name it instead? Has to be. It's just like Nick pulling out the clue of the last problem. Can't I solve for an H or solve for an R if I need to? Sweet, but what was the point of solving for? To plug in. So hold on, let's think about surface area. Is it now important that the can is open on top? Yeah. Because surface area says material. So material, don't we have the sides and the bottom and that's it? The bottom, isn't that just going to be pi r squared? It's a circle. Oh, do you guys remember how to do surface area of a cylinder? What if you were to take off the bottom, there is no top of a can, and you cut it and unwind it? What do you have? Yeah, right? Like think a soup can label. Right? It's just a rectangle. Cut a can, it's just a rectangle. It's a rectangle folded if you guys look at can and then sealed. So we don't have a top, forget that. So since we don't have a top, we can just go ahead and say, okay, bottom. Maybe I should shade that. Maybe I should shade the bottom. But either way, square, and we have the sides are a rectangle. The rectangle, come on, my logical ones. If you cut it and unwind it, the base is going to be what? The height is h, no big deal. But what's the base going to be if I cut it and unwind it? The circle, the circumference, right? And Thomas is saying it 2 times the radius. What's the circumference of it? 2 pi r times h. So I have my length times my width. I know, what am I doing? I'm trying to not just say, well, you better have this memorized from geometry way back in the day or pre-algebra. No, it's logical. You cut it, unwind the circle, that's your base, 2 pi r, and your height is h. Ugh. Come on, you want to make it easy on yourselves. What variable are you going to get rid of, the r's or the h's? Really? Why is it so much easier to get rid of the h? There's only one, and how easy is it to solve for him over here? To do is plug it in one place. Would I make fun of you if you go the other way? No, but I would say, well, you went a hard way. What's the purpose of this? Why am I getting it in terms of one variable? So I can what? Yeah, so I can plug in and derive. But Janelle, am I going to derive right away just as it's written? What am I going to try to do first? Yeah, like simplify, rewrite it, try to make it as easy as possible. Because mistakes happen when you're dealing with it in a complicated way. And some problems, as we've seen from all the critical numbers in the homework 19A and 20A and 21 and the test, derivatives can be hard, but they don't have to be all the time. Because rewriting, look, no prime. Can't I cross off a pi? Can I simplify an r? Right? And I end up with 1,000 over r. If I'm going to make it r to the negative 1, why? Because I love myself a little too much sometimes, but do you like yourselves? Hopefully. Make it easy. Now derive. Why am I deriving? Critical numbers, because I'm trying to find the minimum. Okay. Is it easy? Do you remember pi is just a constant? A coefficient, I should say. Easy as long as you remember negative 1 take away 1 is negative 2. Don't kill a turtle. Don't go the wrong way. We don't use that one a lot, but. Why am I going to rewrite the derivative? Once again, I love myself. Once again, too much probably. But I want a pitchfork, and I can't pitchfork until I have common denominators. Does it make sense why I'm doing 2 pi r cubed minus 1,000 all over r squared? What did I do? Common denominator. You can just be careful of the wording. Does your mind get that I multiplied by r squared over r squared? I end up with r is equal to the cubed root of 1,000 over 2 is 500 over pi. Mental mathers, check me on that. And r equals 0. Huh. I wonder if r can equal 0. Which we probably go do. And we would do minimum, critical numbers, and endpoints. Are there endpoints? Let's think about it. Zero. You can if it's 0. You have like a stick. Anyway, no, it can't be 0. But how big? It needs to be 500. But can h be 0? Because r is 0. Since it's multiplication, actually, r can't be 0, h can't be 0. But h can theoretically be smaller numbers, which r be 500. Ironically, we're super awkward where r can go to infinity. Now think like an actual business that might be actually, or a manufacturing business. Would you actually have your only constraints be 0 to infinity for r? No. Who wants a can that's like a little pipette? Be like, yay, 500. No, that'd be horrible. I don't even know. Okay? So there would be other constraints. They just didn't give us any. So we're like, all right, whatever. I guess they're not really caring about what's like an actual nice, hey, this can would fit in the shelf in a fridge or whatever. Like they should have probably thought of more constraints, but they're trying to make it easy on us. So, okay, fine, whatever. No constraints whatsoever. Cool. Since there are no endpoints, we're not testing them. In a different problem, there very well could be constraints like, hey, this is as tall as shelf goes. Arizona cans don't always fit in every single shelf possible. I guess they figured they just wanted to be different and unique. But long story short, I guess technically we can't go negative, so let's not do that. That'd be kind of awkward. But besides that, we can just throw in our cubed root of 500 over pi. Now, some of you are like, I don't know what to do. Stop freaking out. Can't we say pi is 3-ish? 500 over 3-ish is what, 100 something, right? 120, 130, who cares? It's 100 something. Can't you just plug in 10? Cool. So let's plug in 10 to the derivative. I can't do. Okay, plug in here. 10. 20 pi. 20 pi. 60-ish, right? 10 squared is 100. That's 10. 60-ish minus 10-ish is going to be... Pause, double checking. 10-ish. 20-ish. 60-ish. 10 squared is 100. 60-ish minus... Huh. Why am I a little bit sad right now? I wanted a min. Huh. Something's weird. I just can't see it. Can you guys see it? This is the min. Where's my mistake? Hundred-ish. What's going on? This is a max, not a min, but it is a min. But why is it a min? Huh? No, it's not a typo, because you are minimizing the amount of material. See anything weird? Oh, stink. Never had this problem go wrong before. It would have to do with my plugging in, but my plugging in was great. Oh, cubed root. I didn't cube root it. That's what it was. Look at me telling you guys to be like, this is easy. I mean, it is easy. I'm just dumb and didn't cube root it. Sorry, lo siento. 500 over pi is 120-ish. Did I actually do that right? 3 into 1, 160-ish. But we were supposed to cube root the 120-ish. Hey, can we plug in 1? Or 3? 3 is cubed is 27. Or 4 is cubed is 64. Or 5, should I plug in 10? No. 10's really high, it's above that. Lo siento. 10 cubed is 1,000. That's less than 1,000. Okay. never mind. Let's plug in 1. Yay! So 1 is going to be 6.28-ish. Yeah, that's a negative. Whew. Thanks, Patricia. And yeah, that is a positive. Why is this good? Now we have a min. Not just a min, the min. Because there's no like fluctuation besides strictly going down and strictly going up. Now, who knows? Maybe based on their analysis, maybe the can needs to be actually bigger than this. Here. And there would be no critical numbers, and so in all practicality, the best way to go. But for our analysis, if you're allowed to make a can on this side and on this side with no other constraints, this is the best ideal number to make that radius. What are they looking for? Find the height and radius. So I can say, okay, the radius is going to be the cubed root of 500 over pi centimeters, I believe. And the height is going to equal, you guys know what I'm going to do, right? Plug them in, plug them in. Patricia, you have your calculator. Actually, no, I'm going to be modeling exactly what I tell you guys you can do on long answer problems. What can you do? Stick it to the man, like that nasty motion problem that some of you spent way too much time trying to actually get to be nice numbers when you never had to. Plug it in, 500 over, ha-ha, centimeters. Dun, 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 dun. Now, if you were checking in the back of the book, you should get a decimal because they'll have a decimal and you can check and see if you're right. This one. Could we have mental mathed it from the beginning? See what I mean, Nick? As it gets more complicated. Sadly, the skills are going to fall a little short. So walk me through the problem. Someone tell me the very first thing I did after reading or as I read. What's the very first thing I did? Okay. Sure, H and R. They're the guys I'm working with. What was the second thing I did? I actually asked you guys what you saw, and I think Thomas was the one that saw this one, the 500. No, actually, we went primary, didn't we? Never mind, we went primary. But the last problem, didn't we go secondary? In your mind, who is it, primary or secondary? Is it the main guy whose derivative I need eventually critical numbers, or the clue I'm going to use? Okay, sorry, I did primary first. I didn't even go to the formula. I was like, whatever, surface area. So if that, my clue, I tried to state. I went back and was like, okay, fine, surface area of a cylinder, blah. Plugged it in, then what? Rewrote for the purpose of deriving for the purpose. Then I was like, what did I do? What did we do first? See if there were, because if there were endpoints, what would we have to do? Test them in a table, right? Plugging into the original, who's the highest, who's the lowest. But did we actually have endpoints? No. It makes sense to have a can with the radius being 0. We figured out it was open, then we went where? Sign chart or number line, right? We analyzed, we figured out, finally, we're okay. It wasn't a horribly wrong problem. Next, I figured out it is a min. Why did we plug it in? I went back to the beginning and said, oh, who do they want again? Does that make sense? Let's pause. I don't want to do this one next. No. Fine. I'll go rearrange the slides in just a second. I want to do this one next. All right, guys. I want you to get as much written down as you can, analyzing the problem on your own. I want you to get as much done as you can, analyzing the problem on your own. And some of you might be like, but there's no numbers. It's okay. We'll talk about why it's okay in just a second. Just write down as much as you can. Translate as much as you can. And identify who's the secondary, who's the primary as much as you can. And to be honest, for future reference, if the color coding helps your brain, maybe you should try to color code like me. But to do that, you might need a 4-color pen. Just an idea. Just an idea. That was a meme the other day, but I forget what it was. Something about elementary kids these days want the newest, like, Apple Watch, iPhone, iPad, techie toy, etc., etc. And it was like, back in my day, I would have been happy with this, and it was like a 4-color pen. Like, same. Anyway. Times change. Don't worry about getting to the actual answer. It's weird. There's no number for your clue, but just can you figure out who's who? Who's the primary? Make an equation for him. Who's the secondary? Make an equation for him. If that helps. That's one way of thinking about it, right? 2 squares. I'm gonna start playing. Open top? Okay, so it has a bottom and not a top. Which means it has 1, 2, 1, 2, 3. Not 4, X, Y, and then 1, 2. Only has 5 sides instead of 6, right? 1, 2, 3, 4, 5. Here's something you guys might not realize. If they were to say something, or when they say something like, is to have a volume of V, they didn't express the idea. This is a company that makes some sort of rectangular object, and depending on who's buying it, they might have volume needs. hey, we need to hold this much. And they're like, okay, sweet, that's our constant to use. So the box to fit the needs, which is why we go ahead and length times width times treat V like a constant the whole time. What if it was 500? What if it was 1,000? Treat it like a constant. Thomas, go ahead. Oh, because there's no top. So 1, 2, 3. There's only 3 XYs. Side, side, and bottom, no top. XY is this side. XY is that side. XY is that side. X squared is here and X squared is here. There's no top. Yeah. So guys, what will we do after? And try to make it as easy on ourselves as possible. For the purpose of taking a derivative, common denominators, pitchforking critical numbers, and what do we do with V the whole time? Treat him like a constant. Now I'm going to go ahead and quickly finish this so it'll be on the video, but here's the idea. V is just a constant. We don't have to deal with him in our derivatives or stress about him in our derivatives. He chills along with the 3. You guys can do everything except for a type of problem that says closest, having to do with distance between 2 points. So if you get to anything with distance and closest, just skip it. I think there's one. Just skip it in your homework and leave it till the end, but otherwise, homework due Monday. Attempted. We'll go over questions. Get out of here. Bye, guys. Oh, because volume of everything is length is height. X. It's cubic, 3 measurements. Mm-mm. You're thinking perimeter, maybe? I don't know. Think of. Oh, thank you. I was going quick, not paying attention. Thanks, AJ. You're exactly right. Let's see. Over 1 minus 3v. See you later, kiddo. Good morning. Thinking because x can't be 0, wouldn't be a box. With the multiplication, though, x could be as big as possible. There probably would be constraints based on the situation, but for our purposes, not really thinking about them. So going to a sign chart, don't need a table. Kiddos coming in, don't stress, I'm just finishing a video real fast. I'm not just talking to myself. We're going to test our A prime and our A. Christmas. Throw in our cubed root of negative 3v all over 4. Let's assume that 1 is lower than that, because if somebody wants some product of a volume less than 1, that would be kind of awkward. So plugging in 1, assuming our volume is something to our prime. Ultimately, we can kind of deduce that whatever the measurement is on the left will be negative and positive. So we will end up with our minimum surface area with dimensions of x equals the cubed root of negative 3v over 4. Y equals, you guys know what we would do. We would go back and plug it in. So taking this, going back to plug in, v over, stick it to the man, the cubed of negative 3v over 4. Both of them measured in, oh, they didn't tell us. Depends on what they asked for, probably. All right, guys, dun 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 dun.
That's why I can't find my book.